This is skills practice 48, acids practice. So the first question is, a certain substance in a solution is known to increase the concentration of H3O+. Is this substance an acid or a base? Well, first you need to know that an acid is a proton donor and a base is a proton acceptor. So if something increases so a base is a proton acceptor. If the amount of H3O+ is increasing, then there has to be a substance that's donating that H+ to the water, the H2O. So therefore the substance that's donating that H+, the proton donor, is an acid. Question number 2. So the second question asks, given the following reaction, the H2SO4 breaking off into HSO4 and H+, to identify the Arrhenius acid and describe why the substance you chose is an Arrhenius acid. So first, you just need to straight up know what an Arrhenius acid is, and that's an acid that increases the concentration of H+, as opposed to a Bronsted-Lowry acid, which is a proton, it donates a proton. So since H2SO4 in the reaction ends up losing an H+, it increases the concentration of H+ in the solution, so the Arrhenius acid has to be H2SO4. So the third question is, how do the Bronsted-Lowry definitions and the Arrhenius definitions differ? You need to know what they are. So an Arrhenius acid, as we just said, is an acid that increases the concentration of H+, but a Bronsted-Lowry acid is an acid that donates a proton to a base, so there's a proton acceptor in there. That means there has to be a base present. So now we're asked to describe the difference between a weak and a strong acid for number 4. Strong acids dissociate completely. You need to know this. This isn't something I don't think you can really empirically derive. So strong acids dissociate completely. They are good proton donors. When they react with water, they react completely to form a weak acid and a weak base. So a weak acid dissociates only partially, and they're not good proton donors. When they react with water, they can't react to form a strong acid because the reaction can't naturally go in that direction. Number 5 asks about 3 separate reactions to identify an acid if it's present, and then to say whether it's an Arrhenius acid, a Bronsted-Lowry acid, or both. So if you look at the first reaction, H2CO3 plus Cn minus going to HCN and HCO3 minus, the acid is the reactant with the hydrogen on it. On the reactant side, if there's water present, it's not water, obviously. So the acid here has to be H2CO3. The easiest one to eliminate first, the options we're given, is the Arrhenius acid, because you just have to check if there's any H+ or H3O+ present, and the answer is no. That means that it's a Bronsted-Lowry acid, because the acceptor is the Cn minus. So the HCN is the new weak acid, I guess. The second reaction in question 5 asks about F minus and HSO4 minus going to HF and SO4 2 minus. So the reactant with the hydrogen on it is HSO4 minus, so therefore that's your acid here. The easiest one to eliminate again is Arrhenius acid. There's no H+ or H3O+ present, so it's a Bronsted-Lowry acid. And the third one, HSO4 minus and HO2, H2O. The third reaction is HSO4 minus plus H2O going to H3O plus SO4 2 minus. And the acid is the reactant with the hydrogen that's not water, so that's HSO4 minus. And the easiest one to eliminate or check for first is the Arrhenius again. And there is an H3O plus present, so it is an Arrhenius acid, but also the HSO4 goes to SO4 minus, so it's also a proton donor, making it both an Arrhenius acid and a Bronsted-Lowry acid. And the last question asks, what is the conjugate base of HCN? The conjugate base of an acid is the substance formed when the acid loses a hydrogen ion. When HCN loses a hydrogen ion, Cn minus is formed, so Cn minus is the conjugate base of HCN.